And Kayla.
Fail. Doodlecast. Our Doodlecast is about
DNA.
DNA.
Yay!
Woo! Oops. Woo!
These right here are the DNA strings. DNA strings are different from DNA transferred to RNA. C goes with G, A goes with U, and T goes with A.
Look like this.
Thing, honey. You're on a racer, honey.
Okay.
So the DNA pairs with the RNA, and then the RNA and the ribosome pairs with something else that's holding the correct amino acid.
Like this. A.
As you can see here, this is DNA transferred to RNA. Yeah.
The DNA is paired with the RNA. It makes amino acids.
Many different amino acids. I'll show you what it looks like.
These are the codes for the amino acid.
Another amino code.
Now we're going to talk about DNA mutations.
Yay! What is DNA mutation? Well, I'm here to tell ya. It is changing the sequence of DNA. What are some causes of DNA mutations? Radiation, like UV rays, X-rays, nuclear radiation. Also, carcinogens. These have ingredients of cigarettes and toxins and, the other stuff. Yeah. What effects do DNA mutations have at the cellular level?
Kayla, thanks for asking. So the change in DNA, it would go from the change in DNA to the change in protein. Then it would go from new and non-functioning proteins.
Good answer. Now to talk about transcription and translation. The diagram I'm about to draw for you is basically transcription and translation. So, as you can see, here's the nucleus. And then in the nucleus, there's DNA. Right here. DNA. And right here is RNA. Then we have RNA. So then we have RNA, and then the ribosomes. Rib. And then we have the amino acids. And then we have protein right here.
Very good, Kayla. Very good. I will show you it in more detail. And this is transcription in more detail. Excuse me. So, this is the DNA strand. This, right here, is a protein. So what the protein does is let's say, quote unquote, unzips the DNA strand. And that is what creates the amino acids. Once the DNA is separated from each other, the amino acids would come in and pair itself with the DNA. And that would just make it. And these right here are the RNA strands,
Which is also known as the mRNA, which stands for messenger RNA.
right? And then that right here would make the amino acids. Thank you very much.
Get even more detail in translation.
It's not a competition. Come on.
Whatever you say, Ariya. Now, back to me. Here's a diagram of transfer RNA.
Yes.
This is not the best diagram. For now we'll pair them up. Right on this line. A would be right here. U would be right here. And then G would be right here. Now we'll draw another one. G, A, U. C, U, A. Now they both have a bond. Now they're both bonded together.
So let's say we had a totally different strand of DNA, but only one thing was changed. So let's say that it was A, and there is G, and C, T, and A again. And then it was paired with the RNA. So that would be U, C, G, A, and another U. See, that would change the whole thing. Because what would be changed, like, let's say that G was changed into something different. C was changed into something different, and it was changed into a G, then this wouldn't be right. So that would need to change. And the amino acids that when the RNA and the DNA are combined to make an amino acid and split into 3, I should have added another one right here. But anyway, and split into 3, that would change everything. So a new amino acid would be made, and a new RNA would need to have to come and pair it with that DNA.
Kind of like a new non-functioning protein, right?
Yeah.
Yeah.
Exactly.
Yeah, exactly.
Yeah, good job.
Yeah, okay,
bye.
look.
That's all we have for today. Thank you. There we go. Thanks. Okay. Thank you very much. Ew, she liked me.
That's not fair! I like to thank my mother. I like to thank Josh.
This is not the Oscars. Come on.
Made with Doodlecast Pro.